So, as I just talked about, here's basically all the things that summary of just the stuff we've just looked at. Here's this operator that will delete a path or an element of a path. There are some other things that we've also added in 9.5. There were a bunch of things that we brought in for the JSON type that we didn't have time to get to in 9.4 for JSONb because it was a fairly late entrant. And so we've extended those, provided those facilities for JSONb. Basically, we can turn any element into JSONb, an array, a row, just about anything. And there are these other things which are basically things to build up pieces of, build up JSONb objects in fairly arbitrary ways so that you can pretty much construct these objects with any shape at all. The second thing we did was we had a request to strip nulls out of, to be able to strip nulls out of JSONb to reduce storage requirements and JSON for that matter. And that was something that we added in. And finally, Tom did some work to reduce the cast requirements from JSONb to JSON and backwards, and the other way around, so that all the functions would work more nicely together without having to do some fairly ugly casts. So, we talked at the unconference about some future directions here, so I'm going to talk for the rest of my time about some of those. One of them is this notion JSON Pointer, which is an RSC. Actually, one of the principal authors I noticed today was actually somebody from Salesforce. And it's basically about, is a standardized way of expressing paths within JSON documents. You'll notice that all the functions that we've currently got express paths as arrays of text. The idea would be to change that possibly depending on how well we can get it to be backwards compatible so that you can express paths in the standardized format. Here's an example here. These path and from values are paths in this JSON Pointer format, which is fairly similar to the sort of thing that you see in XPath and other similar languages. This and then there's JSON patch. This whole thing here is an example of a JSON patch, which is essentially a set of operations that you could apply to a JSON document. So you can see, you can test if something is true, and if it's not, then it'll stop. Or you can remove, add, replace, move, or copy bits and pieces of the document. The nice thing about that is that whereas using JSONb set, you can just do one bit at a time, or JSONb delete one bit at a time. Here you can do a whole lot of things all in one hit. And it's actually, if we had this, you would be able to make all these changes much more efficiently than having a bunch of SQL function calls. We'd have one call here which would just iterate over this array and make these changes one at a time.
Yeah, right now I'm nesting JSON set and JSON delete.
Right, so you'd be able to express that much more concisely using this. I mean, it's still a fairly wordy format, but it would be a whole lot more efficient than those function calls. And as you see, it's also an RSC standard. These two standards were written pretty much together, and they're designed to work together. Before I go down that path, my intention is to see how widespread the use of this is, because I don't see, even though they're standards, I don't see the point in adopting something that isn't reasonably widely used. So I'm looking for information on that at the moment, but anything that anybody can help me with on that would be good. Another thing we've discussed, and number of us are interested in. I think pretty much everybody that's having to do with JSON thinks this is a good idea. Is instead of having to do something like JSONb set, is to have this sort of notation, which essentially allows you to address a part of the document as an L value, either to set it or to test it. And that would make the language a good deal more expressive.
If they're working on a standard for a path, wouldn't it? Maybe it's a question of which one.
Well, the trouble is that we want to be able. Firstly, it's got to be something that we can fit reasonably within our syntactic framework.
Yeah.
And secondly, we actually want to be able to do this for more than just JSON. So I deliberately put that up because that's essentially the syntax that you can use today with arrays. And so essentially we're extending the syntax we've already got. Josh wanted an exists operator that's indexable. I'm not sure whether we can actually use the existing indexes for that or not, so we need to look at that.
Yeah, I was looking, JS query seems to have actually figured out.
It'd be nice to have something like that possibly without needing JS query, but there's been some suggestion about that we should be improving the selectivity operators for gin index operations. Essentially, we've punted on that to date, so we need to look at what we can do to improve the selectivity indexes, estimators. And another suggestion that's has been that we should do some sort of schema validation. There is this. I'm not sure that it counts as a standard because it's never been adopted by the IETF, but it's. I believe it's reasonably widely used. Essentially, it's a way of saying, well, the JSON needs to have this shape, and you can say, must have these elements, or and must have so many of these, and so on. It might be worth having an extension which implements that validation, and then you could use the validation function as a check constraint. The query language I'm going to leave entirely to Oleg and Alexander. They're right on top of it. Now, I was blown away by the ambition of their talk today. But it looks like there's exciting stuff happening on that front. So that is pretty much what's been happening on this and what's on the horizon. I think that's pretty much all I've got to say. So, have you got any questions? No? You waving or are you just stretching?
Yes. So I just I'm looking on the blog post proposal. Is Postgres your next JSON database? And the answer is, it's copy on the site, so don't use it. So what can you
I mean, that's the kind of facile judgment, honestly. Anybody who answers that without actually quoting benchmarks is just blowing smoke. I have no patience with that sort of thing. Now, if somebody wants to say, should we be using what's the name of the No. I've forgotten the name. The thing, the guys who are decomposing JSON and storing it in Postgres tables. Yeah, that's the one. So if you ask that, there may well be good cases for doing that versus using our native facilities. There are because they're dissolving away keys in effect into column names. In certain cases, they're saving masses of space, and they can compress things pretty well. There are other cases where it's probably there's probably not such a good case. If Oleg and Alexander managed to bring about this dictionary thing, then probably the case for that goes away again.
There will be some kind of sweet spot where the kind of
Yeah, yeah. I mean, my attitude is generally that you should use this in hybrid applications where you need some of the fairly traditional semantics that we provide in terms of transactional integrity and other things that you don't get with a lot of of what Richard Hipp calls the postmodern databases, but where you need a semi-structured format because you don't know at the time you're building your application exactly the shape that certain sorts of data are going to take. I mean, Josh is dealing with a number of things like that cases like that at the moment, and we don't want to be in the situation where you've got to be all one or all the other. And one of the things that Postgres is really providing for you is the ability to say, okay, this piece of data I'm going to store as JSON, and I'm going to pay some of the prices that we've got for storing JSON or JSONb, and the rest of my data I'm going to store in text and integer and date and traditional database fields. And you can do that very nicely in Postgres. Postgres works very, very well for these sorts of hybrid applications where you're mixing traditional data types and semi-structured data types. Yeah, Josh.
I wanted to actually comment on the whole updating individual datums within JSON in place.
Yeah.
So I'm going to look at the main implementation that supports that, which would be MongoDB's BSON. And there's no free lunch here. The way that they allow updating in place of individual datums is that when they store JSON as their BSON on disk, there's enormous amounts of empty space in there so that they can actually replace things in place without needing to rewrite large parts of the value. And even then, that often breaks down because you can imagine somebody keeps adding values until it fills up the empty space. So they're basically adding a large page fill to the individual data types. And you can actually see this when you start looking at the sizes of MongoDB databases on disk compared to the amount of data that they're storing. If you were to implement another JSON type in Postgres that supported sort of updating individual datums in place without needing to rewrite the whole value, which would be theoretically possible, that would be a fairly substantial trade-off. That would be a trade-off where it'd be like, you only want to use this type if you have really big documents where you do a lot of updating of constant size values in place. And for anything else, you want to use standard JSONb because it's going to be faster.
Except you can't store very large JSON values in Mongo.
Yeah.
There's a maximum size, I think it's 16 megabytes something.
Yeah.
So, and we certainly don't have that limit. Yeah.
This is kind of a philosophical question, but it seems like JS query, this is my first encounter with it, it seems really verbose, and it kind of reminds me of the days of XML query languages where a lot of them were in XML and they were positive typing. Do you have any preference among the query language proposals that are out there? Is there anything that you think is particularly concise?
Well, it's the only one I know of that applies to, that has been adapted for Postgres, right? Are you looking at this, at the one on the thing on GitHub?
Yeah.
Yeah. Because I think there are a couple of things called JS queries, so we need to be careful that you're looking at the right thing. But yeah, I don't know. Is it more verbose than TS query is currently? It's about the same, I think, isn't it?
It doesn't seem to be that verbose.
Okay, I mean, maybe for people who are using JSON and are really familiar with it,
Yeah.
they'll be happy with something that's, what's the word? Homologous to the actual data.
I don't know. Yeah, it didn't look overly verbose to me. But I have not used it, I confess. Anybody else?
So with JSON, we recently saw the problem of this problem of JSON documents that storing numeric structure is actually good. So now Postgres can store big integers, kind of dumps out big integers without quotes. And this breaks mostly all standard JSON parsers and removes the precision. So I don't know.
We store JSON numbers as numerics, which are essentially arbitrarily sized and fixed precision numbers, right?
Yeah, so I don't know what is the standard. So in standard it says
In the JSON standard, it says there is no limit on the size, on the number of digits you can have in an integer. And we are one of the very few implementations that actually lets you do that.
yes. Does it help us?
You need to go to the developer content.
Well, because I mean, you need to. I mean,
No, being able to do more is not any better than being able to do less.
I mean, what
Next question.
what is it you would like us to do?
Are there actually applications that rely on a team of float?
So there are I mean, if you kind of feed the JSON documents from Python into Node.js, then it will kind of remove the precision more or less and kind of convert this big numbers into floats.
Sounds like fun.
That's a terrible thing to do.
There are also lots and lots of JSON implementations have lots and lots of bugs. We can't be bug compatible with, especially when they're with bugs bug compatible. I like that.
Right, there we go. We can implement JSON bug flavors. I want to be compatible with Node.js 1.4.
Does that mean we're actually going to start implementing Oracle bugs too?
Were you in the last talk or not?
The important thing is which flavor of bug compatibility you want needs to be selected by an inline query hint.
There you go.
Yes.
No, I mean, Robert wrote the original parser for JSON, so and did a terrific job, and he was very, very good about staying very, very close to the exact JSON spec. So there's pretty much nothing we fudged a little bit on the encoding issue, but because we have to. That's right. But apart from that, we're pretty much bang on with the spec. And
The problem with it is that everybody has a slightly different idea about how they'd like you to implement, how they'd like you to deviate from the spec.
Yeah.
Back when I implemented that, some people said, oh, we should allow undefined as an additional value. And somebody else had some other idea, and somebody else had some other idea. And there's no end to the things that you can come up with there once you start, and everybody will like a slightly different set of options. But in the end, you have to ship one data type.
Yep.
So we ship the spec.
Yep.
Sorry.
Yep.
I mean, somewhat less sarcastically, this is not a unique problem with JSON world. It's not like Postgres is introducing a problem where, this kind of widespread JSON.
Yeah.
Actually, so kind of the reason for the question was maybe somebody has kind of some workarounds about the problem.
I mean, we could probably, I mean, you could probably create function that would actually would translate the JSON, but I mean, we're not going to build that into the parser. But you know, if you want something that will, you know, I mean, just in the way that we've got we created this new function that will strip nulls at, you could have a function that will, you know, convert numerics or something like that.
And if the problem's going into Python, you replace the numeric graph, the numeric wrapper with something wrapped.
Yeah. Josh.
I was just testing, and the Bloom filter index for JSQuery does check for existence of nested keys.
Okay. Great.
For XML integration, we actually depend on the XSLP and the XML. For JSON, we built all of that in. We not, because I don't think there's one good C library that would depend on, even if there was. But is this, if we build JSQuery, would this be just say Postgres? Because it maybe makes sense to think about a separate shared library.
Well, I mean, what Oleg and Alexander said today was they don't want to build JSQuery into Postgres. So it's currently an extension which is a loadable module. All right.
Yeah, but okay.
And that's what they want to. That's the way they want to keep it.
But still, it's something that's tied into Postgres. It's not a generic JSON.
Well, it's look, honestly, it's going to have to be, because there's no way you're going to have something generic that's going to be able to take advantage of indexing in Postgres. You need to have, you know, an operator class which.
So I even think it's a good idea, because the parallel with with XML and XML schema, which Postgres really supports, and through the XML and JSON.
I mean, we do have XML generation functions, right? We implement most of the spec XML element, XML forest, yada yada yada, right? But I mean, one of the things is there is no indexing of XML at all. All right, and to build it in would be a huge pain. So one of the, you know, if we want to have indexing, we're going to have built-in operations that are going to. Yeah.
Are you really talking about the indexing, or are you talking about the syntax?
Not even. I'm talking about, it looks like for XML, because there was a standard library that everyone was using, we kind of used this and just offload most of the work to the XML, which resulted in security bugs and issues. But still, there was an XML library.
Mostly only for validation. That's about and for XPath queries. That's about all we use it for.
But he's right. You can use those. You can use that syntax in any tool that supports
Yeah.
that. So you're saying like
But I mean,
that then you have implementations depending on how you're storing it.
Yeah, but so the problem with this in the JSON world is that the JSON world external to Postgres has not been able to decide on the standard.
Right.
Is that right? I would say there are more abandoned JSON query formats than there are ones that are in use by anyone.
and binary formats as well of data formats. Yeah.
So I mean, even within the world of JavaScript, like just of you know, querying JSON in JavaScript, there is not an agreed upon way to do it.
Yeah.
We need a JSON con.
Because like when we first started this whole, you know, JSON thing, and Oleg and Peter started implementing JSON query, I did a search for them of over all of the existing standards and polled a whole bunch of developers to see what they were using. No consensus at all.
Even there was an extension before called PGJSON that used an external JSON library.
Yeah. The trouble was that there were all sorts of binary things that you couldn't store in it.
And it wasn't really good. So I mean, this is where
Yeah.
we just went and did our own JSON parser. It's like the Postgres did actually write the parser itself.
Yeah.
So one thing is maybe all this work, if we could ship it as a separate SO, the common bits that
No, we.
and then do the XML
Well, I'm not going to go and rip all that stuff out. No, it's tied in too closely to the rest of this. I mean, we're using string info for accumulating stuff, right? It's tied into the back end very closely. Yeah. Okay. All right. Thank you all for coming.